Hi, Honors Algebra 2 students. We're in Chapter 6, Day 2 notes. Specifically, we're in Sections 6.4 and 6.5, which focuses on rational exponents. In these first examples, we're going to take the radical expressions that were given and we're going to rewrite them in exponential format. If we take the first example, which is the square root of x, and we rewrite it in exponential format, that's going to be equivalent to x to the 1/2. And where that comes from is from the fact that we've got x to the first underneath the radical, and then square root, there's an implied 2 right here. So if we extend that to the next example, if we take the cube root of x, that would be written in exponential format as x to the 1/3. In my numerator right here, I have whatever the exponent is for underneath the radical, so it was x to the first. And then in the denominator here, I have whatever the root was for my radical. So in this case, it was a cube root, so it'll be a 3 in the denominator. In my next example, I have the fourth root of x. That would be equivalent to x to the 1/4. And then if I make it general, so to speak, the nth root of x would be written as x to the 1/n. And again, where that's going to come from is underneath the radical, the exponent right here is a 1, so my numerator becomes a 1, and then it's the nth root, so that n transfers to the denominator. So that's taking things that are initially in radical format and writing them in exponential format. In the next examples, we're going to take things that are written in exponential format and we're going to write them in radical format. So it's kind of the opposite process of what we were just doing. So we've got x raised to the a over b. Whatever is in the numerator goes under the radical with the x in this case. And then whatever's in the denominator becomes my root on the outside of the radical. X to the 2/3 would be written as the cube root of x squared. Now, another way we could write this, just so you're aware, is this could also be written as the cube root of x quantity squared. All right, usually I write it like the first way that I offered to you, but it can also be written as the cube root of x quantity squared. And then finally for the next one, if you notice, we have a number base on this one. So on these last two, we had variable bases. On here, we have a number base. So I'm going to show you two ways in which you could rewrite this. So this could be written as 64, all right? It could be written as the cube root of 64 squared, all right? Or another way we could write it is the cube root of 64 quantity squared. Either one of those are mathematically equivalent. Now, I will tell you with where we're headed in this lesson towards the end, so to speak. The first one makes the number bigger, so to speak, and then it makes it smaller, so it squares the 64, and then it takes the cube root of it. Whereas the second way offers making it smaller first by taking the cube root of 64 and then squaring it. So while both of these are mathematically equivalent to what you see right here, 64 to the 2/3, they're both expressing it in radical format, and it's correct. And if that's all I were doing, I probably would write it like this, and I would probably write it like this. But where we're headed towards the end of the lesson, thinking of it in this way will be helpful. The final thing I want to say before we move on to the next part of the lesson is just the ability to take an expression that's written in radical format and rewrite it in exponential format, or vice versa, is going to be a very important skill for us to use in simplifying different expressions that we're going to have going forward throughout the chapter. In the next part of the lesson, we're going to be simplifying these expressions. Notice the instructions say leave no negative exponents or decimal exponents in your final answers. And you'll see that I will follow those instructions in these examples. But I want to comment on the instructions in your book. Your book on this particular assignment says something about leaving no variables in the denominators. All right, we would rather you follow the same instructions we're giving you here. we want you to leave no negative exponents in your final answers and no decimal exponents in your final answers. And if that means having variables in your denominators in order to achieve those things, then that's okay with us. In fact, that's what we want you to do. So final answers for both these examples as well as your assignment answers, we want to make sure that you leave no negative exponents or decimal exponents in your final answers. And that supersedes any book instructions that you have. As we get started with these examples, keep in mind that we're going to be using the same exponent properties that you've been using all along up until now. So specifically in this first example, I'm going to take this exponent on the outside of 3 and apply it to the product inside the set of the parentheses. The same thing with this exponent of 4, I'm going to apply it to the product inside the set of parentheses. And then I will continue with my simplifying. So negative 2 cubed will give me negative 8. X to the 6th times 3 to the 4th will give me 81, x to the negative 4, y to the 8th. You should also be doing these without a calculator. So knowing that 3 to the 4th is 81, you need to know those things, in other words. All right, now as we keep going with simplifying, 81 times a negative 8 will give me negative 648. If I take an x to the 6th times an x to the negative 4th, I'm going to add the exponents, so I get x squared and then y to the 8th. And that will be my final answer. As I start the next example, I think I'll rewrite it first. So it is a division problem, but I'm going to rewrite it as I'm doing right now, as follows. All right, and that's just straight up a rewriting. I'm going to leave everything exactly the same, other than just to rewrite it, mainly using the fraction division symbol, so to speak. Okay, so if I start with my simplifying, 7 divided by 21 is going to be 1/3. All right, and there's several things I can do when I go to simplify my a to the negative 5th divided by a to the 4th and my b to the 6th divided by b to the negative 2. There's several ways in which I could approach it. I could straight up subtract the exponents here, straight up subtract the exponents here, or I could get rid of my negative exponents first and then go from there. But maybe I'll do this one just by straight up subtracting the exponents. So keep in mind, I'm going to have a to the negative 5 minus 4. So that's going to be an a to the negative 9. Initially, when you're doing that subtraction, it goes in the numerator. And then I would have b to the 6 minus a negative 2. So that's going to be a positive 8. So b to the 8th. Now if you notice, I don't want any negative exponents left in my final answers. So on this particular one, my final answer will be b to the 8th divided by 3a to the 9th. I'll move that a to the negative 9 to the denominator and make it positive. And that is going to be my final answer. Again, I'm fine with there being variables in the denominator as long as that gets rid of a negative exponent. That is fine, and that's what we want. No negative exponents in your final answers. On this one, I should also say too before I move on, when you do this subtraction and you get a to the negative 9, if you know eventually it's going to be in the denominator as a positive 9, you can put it there right away. But I do, when I'm teaching this lesson, go through and indicate initially it'll go in the numerator when you do that subtraction. If it happens to be a negative exponent like this one is, then we'll get rid of it by moving that variable and its exponent to the denominator and making it positive. All right, now in the first example in this section, we had a product. Overall, we had a product. Here we had a division. Here, notice we have a subtraction though. So let's go through initially and just get rid of our negative exponents and see where that takes us. So we're going to have 5a to the positive 2 minus 3a to the positive 1. You know, I won't write it, but to the positive 1 for emphasis. And if you think about it, we're subtracting two terms. They are unlike terms, so I cannot simplify them anymore, so I am done. So 5a squared minus 3a is my final answer. All right, so in this next example, when I'm simplifying my x variable or my y variable or my z variable, I could go through and just straight up subtract the exponents like I did on the example a couple of examples ago now, I guess it was. But why don't I do something a little bit different on this one? And again, you can do it the way I just said, or you can do it the way I'm approaching it right now, just to give you an alternate way of handling these. Let's say we go through and get rid of all the negative exponents first and see where that takes us. So my x to the negative first would go to the denominator and become x to the first. My y to the negative fourth would go to the denominator and become y to the positive fourth. My z would stay in the numerator, my z to the first, because it's a positive exponent. All right, then if I look at my denominator, my x to the negative 2 would come to the numerator and become a positive 2. My y to the first in the denominator would stay because it has a positive exponent. And then my z to the negative 3 in the denominator would move to my numerator and become a positive 3. All right, so then let's go through and simplify between, the x variable, the y variable, and the z variable. So for the x variable, I've got an x squared divided by x, which would become x. My z's in the numerator, I have a z cubed times a z to the first, which becomes a z to the fourth. And then in the denominator, I have a y to the fourth times a y to the first, so that becomes a y to the fifth. And that will be my final answer. So two different approaches. Again, I could take the exponents for the x's and subtract them and then make them a positive exponent eventually if I need to, and that type of thing. That was the approach that I took prior to this one, but then this is also an alternate approach. Both approaches will lead you to the same final answer. All right, so as you look at the next example, you may notice that we have rational exponents. And sometimes students will look at that and say, I don't know what to do with those. Well, here's the thing. The exponent properties that you know are the same ones that we're going to apply whether we have integer exponents or whether we have rational exponents like you see right here. So if we go through and simplify this one, 3 times 4 will give us 12. And then if we're multiplying something with the same base, what do? We add the exponents. So maybe we do that off to the side or down here. If I've got x to the negative 1/2 times x to the 2/3, I need to take a negative 1/2 and add it to 2/3. Well, how do I do that? I find a common denominator. So go back to elementary school, what you learned in elementary school. My common denominator is going to be sixths. So negative 1/2 plus 2/3 ends up becoming 1/6. So my final answer will be 12 times x to the 1/6. All right, so notice I use the same exponent properties. Yes, potentially I need to go off to the side and do my calculations. I cannot stress to you enough how much it is important that you may need to write down adding negative 1/2 and 2/3, switching it to a common denominator, that type of thing. So write down as much or as little as you need to, but don't underestimate the value that can come from going off to the side and writing down your adding or subtracting of the fractions that you need to do. All right, so in our next example, you can see that we have decimals as exponents. Don't let that mess with your mind, okay? We're still going to use the same exponent properties. So for example, when we take x to the 3.7 and we divide it by x to the negative 2.9, what would we do with the exponents in that case? We would subtract them. So I'm going to go down here and do 3.7, all right, minus a negative 2.9, which means then that I'm going to add those together and I would get 6.6. So this becomes x to the 6.6. And then if I did something comparable for the exponents that are involved with y, I would have 4.8 minus 1.8, which is obviously 3, so that becomes y to the third. All right, now we do have a decimal as an exponent, and we don't want you to have any decimals as final exponents. So we want to simplify that for the 6.6. So there are various ways you can think about this, but one of the things that you could do is you could take 6.6 over 1, and you could multiply both the numerator and the denominator by 10, and you would get 66 over 10. And the reason I'm multiplying it by 10 is to move that decimal from the 6.6 to move that one position to the right. And then you could simplify that to be 33 over 5. So my final answer would be x to the 33/5 times y to the third. The other thing I want to mention is there are all kinds of ways, like I said, to get rid of this 6.6. Sometimes students will say, well, that's 6 and 6/10, which is true. It is 6 and 6/10, which is, 6 and 3/5. And then they change that to an improper fraction and they get the 33/5. So whatever works for you. There are various ways of doing it, ways of thinking about it. Perhaps you have another way of thinking about it that you like better. But the final answer for this is going to be x to the 33/5 times y to the third. All right, as we start the second page of notes, I want to reemphasize that on the first page of notes, no calculator should have been used. On this second page of notes, no calculator should be used. The same is true for the assignment that goes with day 2. All right, so the first example that we're going to do is simplify the fourth root of x to the 12th, y to the 7th. So there are various ways you could approach this one, but I think I'll keep it consistent with what we were doing at the beginning of the lesson, and I'm going to take this radical expression and rewrite it in exponential format. So that would be x to the 12th, y to the 7th, all raised to the 1/4 power. If it's the fourth root, it's going to be raised to the 1/4 power. And then we'll use the properties of exponents that we know. So x to the 12th raised to the 1/4 would be x cubed because we're going to multiply 12 times 1/4. And then similarly, it would be y to the 7/4. Okay, and that will be our final answer. Now, as we take a look at the next example and all the ones thereafter, we want you to evaluate these without a calculator. If you notice, all of the following examples have number bases, and so we have the ability to evaluate them. We just want to make sure you're doing them without a calculator. So we need to rewrite these, have the ability to rewrite them and evaluate them. And the best way to rewrite these is going to be the following. We want to take that exponent of 3/2 and use that in a way where we are making the number smaller before we're making it bigger. And here's what I mean by that. We have the option of writing 9 to the 3/2 as either 9 cubed raised to the 1/2, keeping in mind 3 times 1/2 is 3/2, so we could write it like that, or we could write it as 9 to the 1/2 cubed. Again, keeping in mind that 1/2 times 3 is 3/2. So both of those are rewritings of 9 to the 3/2. Well, here's the thing. Without a calculator, what we would be saying on this one is that you would have to take 9 and cube it and then take the square root of it. This one is saying we're going to take the square root of 9 because 9 to the 1/2, remember it means that it's the square root. So we would be taking the square root of 9, whatever that is, and then cubing it. In other words, this makes the number bigger first and then smaller. This one makes it smaller first and then bigger. Without a calculator, you're going to want to go with this route. Okay, so if we now decide that we want to write 9 to the 3/2 as 9 to the 1/2 cubed, 9 to the 1/2 means the square root of 9, which is 3, and 3 cubed is 27. All right, so we want to see you rewriting the original problem so that you're breaking it down into smaller numbers, and then we want to see the evaluation process along the way. In other words, yes, the final answer is 27, and yes, you may be able to do that in your head by going through this breaking down process, so to speak, in your head, but you need to write it down so that we can see what your thought process is. All right, on the next one, I would probably get rid of the negative exponent first. So I would initially write this as 1 all over 16 to the positive 3/4. Then I would go through the rewriting process like I did similarly on the prior examples. So 16 to the 3/4 could be thought of as 16 to the 1/4. In other words, use the denominator first, and then cubed. And again, that's going to be okay because 1/4 times 3 is 3/4. We're just rewriting. Okay, well, the fourth root of 16 is going to be 2. Because it's saying, what do I need to multiply by itself 4 times in order to get 16? Well, that's 2. 2 times 2 times 2 times 2 is going to be 16. So the fourth root of 16 is going to be 2. And then we're going to cube that. So final answer is 1/8. Again, you need to show the rewriting steps, so to speak, to break this down so that you can work your way towards 1/8. Don't just give us a final answer of 1/8. All right, in the next example, notice that we have a negative base. So in other words, that negative with the 8 is part of the base. So we've got a -8 raised to the 1/3, and all of that is going to be squared. And notice on these, you probably have noticed this pattern, but I usually start with the denominator. So I started with, the denominator first, raising it to the 1/2 and then cubed. And then the denominator here, 1/4 cubed. And here I've got a denominator of 3, so it's 1/3 squared. That's the way that we're going to go with making it smaller and then bigger. All right, so what is the cube root of -8? Because -8 raised to the 1/3 is saying the cube root of -8. Well, that's going to be a -2. And then if we square a -2, we're going to get that that's a +4. All right, in the next example, notice we have a -81 raised to the -3/4. Now the negative is not part of the base. Over here the negative was part of the base with the 8 that was being raised to the 2/3 power. But over here the negative is just kind of out front, as I say at times. So we're going to have a negative. We definitely need to keep it. And then I'm going to get rid of the negative exponent. So 1 all over 81 to the +3/4 power. And then if I go through and do my rewriting, I'm going to get that that is -1 divided by 81 to the 1/4, all of that cubed. If you want to check that, 1/4 times 3 is 3/4. So we're accurate on that so far. And then I've got -1. All right, well, the fourth root of 81 means what do I multiply by itself 4 times to get 81? And that's going to be 3. And then I need to cube that 3. So my final answer is going to be -1 all over 27. All right, so in our next example, we have 16 divided by 36, all raised to the -3/2. Now you may notice that quotient, I could simplify that first. Both 16 and 36 are divisible by 4, and so that would become 4/9 raised to the -3/2 power. So you may or may not notice that up front. If you don't notice it, it's fine. If you do notice it though, you could simplify that quotient before you do anything with it being raised to the -3/2 power. Now the next thing you could do, since the entire quotient is raised to a negative exponent, the next thing you could do is you could take the reciprocal of that quotient, and then by doing so, you could now say that that's to the +3/2 power. So we're not going to take the reciprocal of the exponent, okay? We're just going to take the reciprocal of the quotient, so to speak, but you can do that, and then you can raise it to the +3/2 power. And then we could continue on with our rewriting. So that would be 9/4 raised to the 1/2 power, all of that cubed. And then if we continue on with our evaluating, the square root of 9/4, which is what that's saying, 9/4 raised to the 1/2 power is the square root of 9/4. So the square root of 9 is 3. The square root of 4 is 2. We're going to take that entire quotient and we're going to cube it. So 3 cubed is 27. 2 cubed is 8. All right, so there are many ways we could do this last example. All right, you may or may not catch the simplifying of the quotient at the beginning. It's okay if you don't. Whether you handle getting rid of that negative exponent, as I did right here by taking the reciprocal of the quotient and then making that a positive exponent, that is definitely something you can do, but whether you handle it like that or not, doesn't matter. There are other ways you can handle it, but eventually we'll be getting to rewriting this so that we're dealing with a smaller number first, like 3/2, and then cubing it to get to our 27/8. If you have any follow-up questions on this particular example or a different approach that you would like to see taken on this particular example, please discuss that with your teacher in class. For our last example, I went ahead and rewrote it in fraction form, so to speak, using the division symbol that way as opposed to the one that was given in the original problem. Now, the way it's given in the original problem is how it will be from the book problems, so that's why it's in the notes this way, but you may want to pause the video now and rewrite it the way I did. All right, so if we go through and we start with simplifying the numerator, 4 cubed is going to be 64, and then that'll be x to the negative 3/2, because in that case I'm going to multiply those exponents, all divided by, now we've got 9 to the negative 3/2, it looks like, and I'll just leave it written like that for right now, times x to the, now keep in mind we're going to take 1/3 and we're going to multiply it by negative 3/2, and that's simply going to be negative 1/2. And just a little reminder, the reason I multiplied those last exponents is because in this particular case I have a power raised to a power, so I'm going to multiply those exponents. So again, don't underestimate coming over to the side and writing out those calculations if you need to. All right, so continuing on, I think I will do the following. I'm going to go through and say, okay, I'm going to leave the 64 where it is. I'm going to move the 9 to the negative 3/2 to the numerator and make it a positive 3/2, and I'll come back and simplify that later. And then if I focus on the x's right here, I'm going to subtract those exponents. So I've got negative 3/2 minus a negative 1/2, which means I'm going to change this to adding the opposite, which means that's going to end up being, you know, if I really broke it down, that's going to end up being negative 2/2, which is going to be negative 1. Not sure how many steps you need to think through on that one, but it is going to end up being x to the negative first. So initially it would be in the numerator as x to the negative first, but it will indeed go to the denominator eventually and become x to the positive 1. All right, now to finish this one off, we've got to evaluate 9 to the 3/2. Well, as luck would have it, there's an example up above where we found that 9 to the 3/2 is equal to 27. All right, and 64 times 27, you could multiply that out by hand because you should be doing it without a calculator, is 1,728, all divided by x. So that's going to be my final answer. Now keep in mind, if I had not already figured out what 9 to the 3/2 was, I would need to go through and think about that as being 9 raised to the 1/2, which is the square root of 9, which is 3, and then I take 3 and I cube it, and I get 27. But you would need to write out the work for that to show how you came up with your 27. But to save a little bit of time, it's done in a prior example, and I could just reuse that. All right, so just to reiterate, you should be doing all of this on your Day 2 assignment with no calculator. And I will also say the following, that, you know, these problems, there are more steps that you should be writing out than not. So sometimes they look like these sweet little innocent problems. And yes, on some of them you may be able to do them in your head, but we always remind you we can't grade what's in your head. It needs to be written down. So you need to show the process of rewriting these and doing your evaluation along the way, as well as obviously stating your final answer, all doing it without a calculator. This wraps up our Day 2 notes.